Hello and welcome. Today we're going to discuss solving quadratic equations. Previously, we've learned how to factor quadratic expressions. Now in today's lesson, we're going to take those expressions and change them into equations. First, I'd like to discuss solving this equation 5a equals 0. If you are multiplying two numbers and the product of the two is 0, one of those two has to be 0. So here I've got 5 times a variable a. The product of those two is 0. Because I'm multiplying these two things together and getting 0, my only option for the value of a is that a must equal 0. Now if we go through and actually solve this using properties of equality, I can divide both sides by 5 to undo that multiplication and isolate the a, divide the 0 by 5, and a equals 0 over 5. Since 0 is in the numerator of a fraction and not the denominator, this simplifies into simply 0. So again, because we are multiplying two things and the product is 0, the only option for your variable is that it must be 0. So let's consider the following for a moment. A times b equals 0. You've got two variables and their product is 0. Well, the only difference between this equation and the one above is that instead of a 5, we have a b. Instead of 5 times a equaling 0, we have a times b equaling 0. Well, again, we are multiplying two terms together, and the product is 0, so at least one of those two terms must be 0. If a equals 0, b can be whatever it wants. As soon as it's multiplied by 0, then the product is automatically 0. Or maybe b equals 0. If b equals 0, then a can be anything. As soon as we multiply it by 0, then the product is 0. So your two options for solving this equation are that a can be 0 or b can be 0. That brings us to our zero factor property. The zero factor property says, if the product of two or more factors is 0, so above I have the product, which means multiplication, of two factors. Here they are a and b. And the product is 0, then at least one of the two factors must be 0. To translate in a slightly different way, if we multiply two things and get 0, one of them has to be 0. So again, I multiplied a and b and I got 0. So either a or b has to be 0. So what about this? What if we have a quadratic in factored form, x minus 1 times x minus 2. We multiply those two factors together and we get 0. So what I have is the product of two factors. That is what I have on the left side of my equation. This product is 0, and that's on the right side of the equation. Because the product of these two factors is 0, one of the two things, or maybe both of them, must be 0. So all I'm going to do is say the first factor, x minus 1, that can be 0. If this whole factor, x minus 1, is 0, then it does not matter what this second one is, because as soon as we multiply it by 0, then everything becomes 0. So x minus 1 can be 0, or maybe that second factor of x minus 2 equals 0. Again, if this whole factor is 0, then as soon as we multiply it by the second factor of x minus 1, the product will be 0. Solving both of these equations, we can find the solutions for our x values. Adding 1 to both sides of my equation, I find that x can equal positive 1, or on the right, I'll add 2 to both sides of the equation, and I find that x equals a positive 2. So there are two solutions for this equation. X may be 1 or x may be 2. I'll go through and check my answer really quick just to be sure that it works. Step 1, I'm going to try x equaling 1. Plugging in a 1 on the left, I get 1 minus 1, and the factor on the right becomes 1 minus 2 equals 0. 1 minus 1 is 0, times 1 minus 2, which is negative 1. is 0. 0 times 1 is in fact 0, and 0 equals 0. That is true. Now I'm going to try the second solution, which is x equals 2. Plugging in a 2 in the factor on the left, I have 2 minus 1. And the second factor is 2 minus 2. Their product equals 0. 2 minus 1 is 1. 2 minus 2 is 0. And that should equal 0. 1 times 0 is 0, which does equal 0. So this works as well. So you have two separate solutions. The first is x equals 1, and the second is x equals 2. We're going to now go into solving quadratics by factoring. On the last slide, I gave you an example of this. Now we're just going to go a little bit more into depth. By definition, a quadratic equation is an equation with a variable raised to the second power. There is no higher exponent. Another way to say this would be a second degree polynomial. That word degree is just talking about the highest exponent in your polynomial. So since this is a second degree polynomial, it means that the highest exponent in your polynomial is a 2. Here are some examples. 2x squared, since there's an x squared, it is a quadratic, plus 4x minus 6 equals 0. X squared, again, since there's an x squared, and that's the highest exponent, this is a quadratic. X squared plus 1 equals 10. And negative 4x squared equals negative 16. Again, since the 2 is the highest exponent, it is a quadratic. These must have an exponent of 2, and there may be nothing higher in order for it to be a quadratic. When you are solving quadratic equations, your goal, as in any other equation, is to find the value of the variable that makes the equation true. Our method to solve is we are going to first set the polynomial equal to 0, and then factor the polynomial completely, as we've been discussing throughout this unit. Once we have factored the polynomial completely, we're going to use the zero factor property, as we did on the previous slide, to solve each factor for x. On this page, we're going to go ahead and practice solving quadratic equations. Step 1. Ensure the equation is equal to 0. So looking on this entire slide, every equation is already set equal to 0. If not, which we will address in later lessons, then you must make sure that there is a 0 on one side of your equation before you proceed. Step 2. Factor the polynomial completely. Again, all of these have already been factored for you, so we do not need to worry about factoring. All we're going to focus on is step 3. Apply the zero factor property. To apply the zero factor property, what we need to see is that there are two factors being multiplied together and their product is 0. So that means each of the two factors may be set equal to 0 to solve your equation. If either one or the other equals 0, then the whole equation will be equal to 0. So solving each of these, just as I did a couple slides back, my first solution is that x equals 1, and my second solution is that x equals 2. Both of these are solutions to your equation above. Down on the left, I have two factors of this polynomial. They are multiplied together and the product is 0. So what I'm going to do is set each factor individually equal to 0 and solve. So x minus 5 equals 0, or x minus 3 can equal 0. Adding 5 to both sides on the left, I find x equals 5, or on the right, when I add 3, I find that x can equal positive 3. And these are two solutions to your quadratic above. Since I have two factors whose product is 0, I set each factor individually equal to 0 and solve. These are a little bit more involved because you have a coefficient in front of your x, but we still go about it the same exact way. I add 9 to both sides to find 3x equals 9. Divide both sides by 3 and I find x equals 3. Or, on the right, I add 8 to both sides to find that 4x equals 8. Dividing both sides by 4, I find that x equals a positive 2. And on the right, I have two factors again whose product is 0. So that means that either one or both of the factors must be 0. So I take each factor individually and set them equal to 0 and solve. On the left, I subtract 5. 2x equals negative 5. Dividing both sides by 2, I find that x equals negative 5 over 2, and we will leave it as an improper fraction. Or, on the right, I subtract 8 from both sides. So 3x equals negative 8. And dividing both sides by 3, I find that x equals negative 8 over 3. Reduce if you can, and then leave it as an improper fraction. So your two solutions are x can equal negative 5 over 2, or x can equal negative 8 over 3. Now, it will not be both of these solutions at the same time. When you go back to check your answer, you only plug in one at a time. So if I wanted to check negative 5 over 2, I would plug it in for both x's in the equation. And then if I wanted to check my negative 8 over 3, I would again plug it into both x's in the equation. So your solution is only one of these at a single time, but either of the two could be a solution. Please go ahead and take a moment to pause the video and try the next 3 on your own. For the first, x can equal 7 or x could equal 9. In the middle, x should be negative 7 over 5 or negative 3 over 2. And last, x could equal 1/2 or x could equal negative 9 over 4. On this next and last slide, we are again going to factor and solve the following quadratic equations. Step 1, just to recap, ensure the equation is equal to 0. Well, in all 4 of these, that has already been done for you, so we're just going to focus on steps 2 and 3. Step 2, factor the polynomial completely. In our first equation, on the left of the equal sign, I see a trinomial. In order to factor a trinomial, we need to use the diamond method. On top of my diamond is a negative 3. On bottom is a positive 2. My two factors that multiply to negative 3 and add to positive 2 are positive 3 and negative 1. So I am going to rewrite my positive 2x as positive 3x minus 1x. I still have the x squared in front and the minus 3 behind, and it still equals 0. Now on the left, I'm going to go ahead and split that down the middle. I take out a greatest common factor of x, leaving me with x plus 3. And on the right, the common factor is 1, but since the coefficient of that first term is negative, I'm going to factor out a negative 1, leaving me with x plus 3, and it still equals 0. Now I take out that common factor of x plus 3, leaving me with x minus 1 in the second parentheses, and it still equals 0. Now from here I have two factors whose product is 0. So I may take each of these factors and set them equal to 0 using the 0 factor property that we did on the last slide. So either x plus 3 equals 0 or the second factor of x minus 1 equals 0. Solving the equation on the left, I find x can equal negative 3, or solving the equation on the right, I find that x can equal positive 1. Either of these two x values could be your solution to the original equation. On the left, again, it is already set equal to 0, so we simply need to factor. I factor out the GCF of 2, leaving me with x squared minus 9, and it's still equal to 0. Now notice we have the difference of squares. X squared minus 9 factors into x plus 3 and x minus 3. It's still equal to 0. Setting each of my factors equal to 0, I have x plus 3 equals 0, or x minus 3 equals 0. Solving the first equation, I find x can equal negative 3, or x can equal positive 3. So your two solutions are x equals negative 3, or x equals positive 3. Go ahead and take a moment to pause the video and try the next 2 on your own. First, you should have x equals negative 3 or negative 2, and on the right, you should have had negative 2 or positive 2. Remember, you needed to factor out a -3 first. Thanks so much for watching and enjoy the rest of your day.